Good morning, everyone.
Good morning, Joe.
Rob had a good idea here in that we're going to change how we do these lessons now. You guys all have the basis. You all know how we led up to getting the house in. So now what we're going to do is take you through once a month the progress done on a particular project, this one being 1860. So you could follow the construction and everything that we spoke about earlier. Devin is narrating this. This one is going to take it from the installation of auger piles, but just a quick recap of what's happened before. Okay, the intention here is that you get to follow the construction of the house from start to finish. You get to see the phases and you get to incorporate the things that we discussed previously. This should be pretty much self-explanatory, but if there are questions you have, come speak to me, speak to Marion, speak to Carl. You know, we've all been through this. You can speak to Rob. Hi, Rob. Okay, so Devin did most of the narrating on this, so you're up.
Hey guys, I'm Devin with RWB Construction Management. We're here on site with our 45-foot auger drill bit. We're going to walk you through the process of drilling auger piles today. Let's go check it out.
Up to this point, we've been talking about the procedures leading to the installation of basically the construction of the house. We've gone through sheet piles. We've put in the piles at this point. We have put in seismic readers to make sure we don't exceed the vibration levels, making it unsafe to the neighbor's properties, and to protect ourselves in case there's an issue. We've gotten the geotech report, which does specify the length of the pile, the diameter of the pile, the construction of the pile. The assembled cages take approximately 2 weeks to put together. There's 257 of them. When they're laid on the rack, as you see, someone comes by, takes the spacing based on the engineering report, paints a dot on one of them, which allows them to locate these hoops correctly. And once they're done, they're moved over into the stack. In this case, all of them are the same. So if you look on the video, you'll see spots of either green or white paint. Those are put there by the assembly crew once on the horses, so they know how to locate the hoops. Elevations are usually set for a auger pile installation roughly 2 feet below the finished slab. In our experience, we found that that works out well, leaving enough fill with the spoils that come out to bring us pretty much up to grade. RWB procedure is those spoils are mixed in with the grade as this is done. Hardened material is removed afterwards and stacked and removal from site.
This also helps us save a lot of time and money. When he's mixing it in, it helps solidify the ground. When the other trades come in for the underground work, electrical, plumbing, mechanical, they're able to dig it out and it's not so sandy, especially since we build on the beach a lot. It saves money because we're not having to come back and spend a lot of time digging up solidified concrete chunks and having to move them around the site and dispose of them.
It also allows us to relocate soil so we don't cover up the flags remaining and blocking us from being able to put future piles in.
Earlier we saw the engineer confirming which number is on this piling. Each piling has its own number, so we can identify them separately. On this job we have 256 piles being put in. As the drill bit goes down, they have two criteria that they need to meet. One is a specified depth that's been decided by the engineers, and or they hit refusal, which means they just can't drill anymore. They've hit something hard down there, hard soil or limestone or a rock, and the drill just won't go down anymore. That means they hit refusal. The way they decide refusal is between the crane operator and the engineer that's on site at all times. So the engineer will give the signal saying, yep, you hit refusal, you can't go down anymore. That's good. Then they start the process of the concrete being pumped through the drill bit. This gentleman with the rope and the pulley, they've connected the other end to the rebar that needs to be put in the hole once the concrete's been pumped into it. So what this does, as the drill bit gets lifted up and the concrete's being pumped into the hole, it actually is lifting the rebar up with it. So here they're removing the drill bit and pumping the concrete at the same time. Everything is monitored. The engineer actually gets the truck number for the concrete truck and correlates that with each pile. Even before the concrete gets pumped, they check the mixture in the truck to make sure that it's correct. So now he's going to lift up the drill bit in the cage. And raise the rebar cage high enough to go into the hole. So now they bring the rebar cage up and they're tied on the end so they don't get caught on anything as it goes down. Now they just guide it, slowly release it and lower it. And it just slides down in. There you go. It hit the bottom, now they unhook. And they start moving to the next one. They can't do two piles too close together, otherwise it'll collapse. So if they have two piles that are really close together, they'll end up doing one, moving to one further away, and then coming back to the other one.
Okay guys, so you get approximately 20 to 25 on a good day, piles per day per area. Okay, you have to, when they do this, they have to plan out the path because they're going to be putting them in, but they can't block the trailer, so they'll get whatever they can get with the crane in one area. And they'll move it and they'll do the next one, but they always have to be conscious of not backing themselves into a corner. Okay? Anybody got any questions on how this happens?
All the rebar gets delivered and then they build the actual on-site, or?
In this case, they built on site. In most cases.
Can you back up 1 second though? Can you talk specifically about the rebar? It's not what Devin labels as rebar in that video is really the cage,
Okay.
which is tied rebar. So you can go back, explain where we find and get told how that cage is
Okay.
like the size of rebar, the hoops, everything.
Okay. Well, first of all, if you remember, we were talking a couple of weeks ago about rebar. We had hoops. We showed how a rebar is put together, wired, and there's a loop, like a hoop that goes around. With these, they're round. Okay. The engine. If you look at the report from Beacon on the geotech report, it'll tell you 14-inch diameter, 40 feet long. It's in that report. I printed out. Everybody probably has one somewhere. Look at that page. If you have a problem, I'll find it for you and I'll show you. It'll tell you the number rebar, whether it be number 5, number 4, whatever. It'll tell you this. And remember before we talked about the offset of the hoops. It'll tell you how far apart they go. It'll tell you what size they are, number 4, number 5, and how long they have to be. Okay. They'll wire this whole thing together and they'll tie the end so it comes to a point so it doesn't get caught when it goes in. Most of the time, these cages, they're not called rebar, they're called rebar cages. Most of the time, these cages are done off-site. Okay, they're built in the plant and they're brought in. In this case, we didn't want to wait. We wanted to get work on site, we wanted to get it done. We brought the steel in and they built them here. Most of the time it's not built here. Most of the time it's brought in on trucks and it's dropped off. We wanted to get a little jump on this, and they didn't have time to start it at the shop. They said, bring it here, we'll do it here. Okay? The geotech report from, in this case, Nutting, works with Stoddard. If there's any questions about how the design is, does it need to be? If you guys remember a couple of weeks ago when we talked about some of these things, I had mentioned that, you know, I asked Stoddard, I asked everybody, why do I need a 40-foot pile to hold up a wall that has no stress on it? That's a coordination between the geotech and the engineer, okay? Guys, remember, the length of these piles is determined by the geotech based on the soil conditions it's going through. In this case, they're 40 feet long. That's very long, okay? The reason it's so long is because halfway down, it's all muck. It's organics, whether it be tree roots or whatever was thrown in there 100 years ago. It's not stable to support anything. So the engineer will look at it and determine how low it needs to go, okay? When you get these geotech reports, look at the soils, okay? Now, you'll hit refusal on some areas. If this whole thing is the site, you know, they'll do a bore here, they'll do a bore here, they'll do a bore here. That doesn't mean over here there's not a section of limestone or a section that they're not catching because they're taking specific points. They're not taking them every 3 feet. So they can't say if it's going to go down and hit a rock or not. Understand? The other thing you guys have to understand is there is a height that these piles are supposed to be before the rebar gets bent into the grade beams or into the deck or whatever they are, okay? If they don't put the grout to the right height, they're going to be coming back later and chipping it all out, okay? Because if the hole is too deep, not too deep, but is too high, when they finally separate it and grade everything to the right height, they're going to have a piece of concrete that big that they got to chip out to expose the bar. So generally what we do is we have the subcontractor come in who knows the elevation that this grout has to be in. It's easy to displace grout while it's wet. You take a piece of 2x, you push it in, the grout comes out. Getting it to the right height during construction or during the installation of the piles saves you time and money later. Okay, you understand that? Now, longer piles take longer to put in than shorter piles. When you plan your schedule, usually we plan 20 to 25 piles a day. There are days you'll get more, there are days you get less. But it's important to figure out how many piles you have total, and then try to figure out a schedule of how long it's going to take so you see what else. When you got to plan your grade guys, you got to plan your plumbers, you got to plan everybody else. You have to be able to plan ahead. You have to use a number. Usually it's 20 to 25. We try 25. To determine how long it's going to take to put in 250 piles, okay? Then you can plan ahead, okay? It's important that you have a plan before you start this with where the grades are. Not just the grades of the soil for the deck, but for example, we talked about pile caps. Pile caps, because they're going below the beams, are going to be much lower, right? If the beam is here and I have a cap that sits underneath it, the height of that pile is going to be lower, right? So it's important that you know the height that all these piles have to end at. That way you can get the soil, you can get the excess grout and concrete out. If not, you're going to lose a week chipping all this stuff. It's much easier to coordinate with the subs before time. In this case, we have a drawing. If anybody comes to 1860, there's a drawing on the wall. It's color-coded to what height everything's got to be at, what elevation. That way when they go in, they displace it, they don't lose time. If you don't do that, then you get all done, you go to put your underground in, and you got guys sitting there for 2 weeks chipping piles. Doesn't help you. You're trying to save time. In order to save time, you minimize the work you have to do afterwards. So you understand how long it's going to take you to do it, get an idea barring rain or breakdown of equipment or whatever. Make sure everybody's got the right heights and you can all plan, okay? Cages are just like putting a grade beam in, okay? It's a cage with a loop and everything's set. It's a structural element that's got to go in right. One of the things that's important is at the end of that, you will get a report from the engineer verifying that those piles were put in as per directive. Okay? There are inspectors who will ask for that report before they'll give you a structural inspection on your beams. Doesn't always happen, but most of the time with private inspectors it will. Okay? You'll get a drawing that we showed you last time where every flag has a number. Remember we talked about that? Okay? You see flags. What you don't see on here too clearly is there's a stake that goes under that flag. Because the flag just represents a number. They're hitting that stake. It's important that you have documentation. You know what piles were done. You have the engineer saying it's either hit and refusal or it's hit in depth. And that you have the proper cages built based on a design from the geotech and the engineer.
Joe, can you just talk a little bit about how the piles are laid out on the job site, the stakes?
The stakes?
Yes.
Okay.
Who lays
So
them out?
before we start, and I think I distributed and I showed you guys a plan. The surveyor comes in. It's a lengthy process, and he literally goes out and flags every pile. Now make sure you get an AutoCAD file, so the AutoCAD file can go to the surveyor. From that file, he can get the coordinates to lay out all those stakes. Okay? When he comes out, he'll do it. He'll drive a stake, he'll put a flag, and he'll put a number. The number on the flag will correspond to the number on the plan. Okay? If for some reason you walk this and you're missing a flag, you better find it. Okay? One of the things that happens is 3/4 of the way through the project, you walk the site and you're like, I'm missing one. Or one got covered up by spoils. You got to make sure that you have everyone in place. Okay? If you're missing one, a couple of things can happen. If it's in a straight line, you can get the distance off a CAD file, you can locate it. Okay? Or you can call the surveyor back, but you can't just wing it. Because that pile is put there for a reason. Okay? Most of the times, if you know roughly where it is, you can dig down a little bit and you'll find it. Okay? But the surveyor will come out and mark it. What happens after this, which is really important, and we'll get into in the next plan, is you'll call the surveyor out and he'll mark the perimeter of the building. We had talked about batter boards and setting it up. Anybody who comes by 1860 will see that now, and then you get a form board survey. The form board survey, the only reason I bring it up is because it relates to the piles. Okay? Sometimes a pile doesn't go in exactly where you want it. It's not millwork. You got a 40-foot thing, you got a stake this big, he's got to hit it. Sometimes he hits it, sometimes it slides, sometimes it goes on an angle. When you get your form board survey in, you'll see the piles running around, and you'll see if you have any conflicts on the perimeter. One isn't right. One isn't right, don't freak out, we can deal with it. Okay, you go to the engineer, you give him a spec, he'll give you a detail, and we'll get it taken care of. The earlier you find all this stuff, the better.
Joe, do we trust the surveyor when they're laying out floorboards, or do we go back and forward on measurements off property line?
We do both.
Guys, do you hear that? Surveyors are imperfect, just like we are. They make mistakes. If you guys rely solely on what the surveyor has come out and marked on your project, sooner or later, it'll hurt.
Okay, the surveyor is also not going to give you every corner of a building. Okay? The building's going to go over, back, over, out, back, over. He's not going to mark every point. When we did 1860, I sat down with S&D. We took 3-foot offsets from certain points and we developed a plan that we sent to the surveyor. Okay? From that plan, he gave us stakes. Now we know from that stake to that stake, that's the back of the building. What happens is you have to make sure you have some way of determining what the dimensions of that form board are, because they're not always on the plans. Okay? He's not going to give you every corner. When you're done, take the overalls. Check them all, but check from, like on ours, it was 140 feet, I believe, from one side to the other. We were 140 3/4. When we measured off the property line, we were 24.98. Guess what? You add 3/4 of an inch to this board, brings you to the property offset. You have to check your offsets to your form boards. Because if you put the form board in and your offset isn't right, When you build the wall, you're going to be too close to your backside from the side of the property. Okay? This is where you find all your mistakes. This is where you make sure everything's right. The other thing is everybody else who's laying out beams, laying out plumbing, laying out electrical, is laying out all these rooms based on that form board. Okay? So if that form board's right, everybody's right. If that form board's off, then everybody's off. When you go, you won't find it until you get the walls up. Right? What do you got?
You were talking about being below the slab by 2 feet. A lot of those cages stood up way above. Is that by design?
The cages, okay, the cages come up because in the drawing that we have, the cages bend over. Because you have to use, we got a letter from the engineer that we can use a hydraulic bender to bend those over, okay? And there's a distance on the drawing that they have to extend into the grade beam, because that ties, it basically a web between the pile and the grade beam. So they sit up high. They'll cut them to the right height, okay? And then they'll get bent over into the form.
But the concrete, Scott, is set at that, when they fill the pile up, the hole, that is what's set at the 2 feet below the slab, because the grade, that's basically the bottom of the grade.
Yeah,
So
but
the cages are built to a certain length. If you hit refusal before that length, obviously your cage is gonna stick up much higher. At that point, they come in, they cut the excess, they bend over what they need.
and they put an orange cap on them. Okay, it's very important, especially with piles when they're cut, that there's orange safety caps on them. Because you got to figure, you're walking through an area where there's a pile every 3 feet, you fall down on one of those, you're going to hurt yourself. Okay? Going later on, we'll show you in the next bunch of films how the piles get integrated into the grade beams. But don't forget, you're not just going into grade beams. You're going into grade beams at this level. You're going into pile caps a foot below that. You're going into the deck a foot over that. So they're not all at the same elevation. So you can't just arbitrarily cut them all. You can't just arbitrarily set all the piles to the same height. Okay? That's why you need the coordination meetings before time, and that's why everybody needs to agree on the heights you're going to go to. And that conversation has to not only go with the shell contractor, but also with the contractor putting in the piles. Okay?
Can you explain, in this project specifically, we have a main level pool, which means it's essentially the second floor of the house. Because of that, can you explain where those pool piles are and how we're going to deal with those pool piles?
Okay. Like Rob said, this pile, this house is actually not your typical. Most of the houses we build, the pools are at grade level, right? Everybody's seen them at grade level. Here, the pool is up on the first floor. That poses a problem for 2 reasons. One reason is, you're building part of it and you're coming up, right? The second reason is because this house, the property line to the back is very shallow. So if I put that pool pile in now, I'm cutting off my access to the back. So this has to be a plan that you figure out means and methods early. I'm going to do this, I'm going to leave this open. So in this case, what we did is we put the piles in. We didn't cut the pool piles, we made them long. Because what's going to happen is the bottom of that pool, when we form it, is going to be 8 feet up from the lower level. So phase 1, you build a house proper, and you leave the rebar sticking out to extend it further. Phase 2, after the lower level is in and the walls are up, you waterproof all those walls ahead of time. And then the first floor slab is going to extend all the way out to the pool. So in this case, what we're doing is we're bending the bar over. We're backfilling over it so we have basically a road that lets us access the back of the house. We have to move a tree, we have to bring in riprap wall, we have stuff, we have no room. So phase 1, lower level slab, lower level walls, waterproofing, because after we get all that done, we're going to build a wall to the pool and backfill into it so we can pour the deck. All the piles for those areas are already there. In this case, what we're going to wind up doing is probably extending them. You put a sonotube in, you got a detail from the engineer on extending the rebar up to go from the lower level to the upper level where the pool is. You tie everything in just like you did at the grade beam. But there's phases, and if you don't think those phases out, you get caught. If you build the back of it, you're like, oh God, now I can't get back there. I can't put the riprap, I can't put the wall, I got no way to get there. You have to think of the phases you're going to do, the means and methods, and how you're going to put this whole thing together. Okay, it's a big puzzle. It's a big erector set. And you have to think of things like, you know, I have to make sure this wall gets waterproofed before I backfill to it, or I'm going to have a leak in my garage. I got piping that have to come out. Does it go through the wall? Does it go under? All that stuff has to be figured out ahead of time. Basically, you have to build this thing in your head and on paper before you put a shovel in the ground. Every time we have one of these classes, I say the same thing. It's easier to fix it on paper than it is once it's up. In this case, it's all phasing, okay? Likewise, once I get that house in, the first floor proper, and the slab goes all the way out to the pool, now I have a manifold that holds this whole thing together. Now I can take those sheet piles out. Once everything's waterproofed, now I have access to the whole site. So this is the first step. We're planning on pouring this in about 3 weeks. We'll do a section. But again, all this has to be figured out ahead of time. That means underground plumbing, HVAC, electrical, low voltage out to security, water lines, septic lines, storm drain lines, where they're going to tie in. Everything has to be figured out ahead of time. Okay? You have to also figure it all out in conjunction with the pile locations, because you can't run lines through. In this case, we have things located that have to go under certain things, like they have to go under exfiltration fields, they have to go under drainage. So we had a very low excavation for piping for the generator, going out to the generator, going out to things. They're actually going to run way below the beams. There are electrical pipes that are going to run within the grid for electrical boxes and things like that, 1-inch lines. But in this case, it was multi-layer because we had to get them low. And we had to come at a point where we could pitch to the septic without having an issue that we're going up. So all that has to be planned. But all these phases, including prepping for the pool. You know, in this job, what they told us we were going to do is we were going to build the pool and then pour the deck to it. If we did that, there'd be no way to support that deck going to the pool. So we met with the engineers ahead of time and said, no, we're going to put a wall here that's going to be on this side of the pool so that it can sit on that wall, and that wall will be on piles. Okay? The other side of the pool, we're going to have an overflow, and we're going to run an inner wall up so that when we put the pool, we can pour straight down over that wall so we don't have a crack. All these things have to be thought out. What we're building now, and this whole scenario of A, B, C, D, what comes first, what comes second, all this was planned before we ever cleared the site. Because if we didn't, we would have had all kinds of problems later on. So again, you guys know, if you pour two things and one moves, it cracks. You got to think of all that. You got to think of the waterproofing, you got to think of the roughing, you got to think of how you're going to get from point A to point B. All right? What do you guys got? Any questions? Okay. Anybody wants to see the site, by all means, give Devin a call, give me a call, we'll go explain it. Anybody has any questions, there's plenty of us you could talk to. Okay, the video is a really good representation of how this stuff goes in. But again, it doesn't mean every job is exactly the same. You'll come with different conditions, you'll come with different soil conditions. Like even now, we're still working out the details for the site walls because they changed with the elevations. It's a moving target, okay? You got to make sure you're ahead of it. All right, anybody have any questions? No? Thanks a lot.